polar form that is 10 and 50 degrees. So I would like to make a component analysis of this vector. So the magnitude of the vector is 10 and the angle it makes with the positive x-axis is 50 degrees. All angles here are in standard position. That means that all angles are coming from the positive x-axis. So that doesn't mean that our angle is always in the first quadrant. It could be anywhere in the quadrant. So we will take first an example for an angle in the first quadrant. I would like to find the x component and the y component, and then later on we will extend our understanding of changing this into a complex form. So we already know that our x value is equivalent to r cosine theta. Alright? And our y value is equivalent to r sine theta. You shouldn't be lost because alphabetically speaking, x comes first before y and cosine comes first before sine. So that it's easy for you to remember. Now all we have to do is to plug in the values in our formula. So our r is 10 and our angle is 50 degrees. Here, our r is 10 and our angle is 50 degrees. So if we're going to make use of a calculator to find the values, so you have, this is already in degree mode. You have 10 cosine 50, and that would be the value of x. And it's equivalent to 6.43. Okay, so to find y, you have 10, and then you have sine 50. And that's equivalent to 7.66. So if we put our answers in the figure, so our x value is 6.43 and our y value is 7.66. Now when you go to college, you will have to be given certain structure or specification for complex polar form equal to RCIS. What is the meaning of this? Now we know that our complex number is in the form a plus bi, which a represents your x and your b represents your y. So therefore, we know already that our x value is 10 cosine 50 to be exact, and our y value is 10 sine 50 to be exact. That is the reason why our vector, which is also our complex number, is equivalent to 10 times cosine 50 degrees plus, there's I here, I sine 50 degrees. That is the term R6 because you have the radius, you have cosine. It's an abbreviation of complex numbers. So we can also like express our polar form into a coordinate form. It can also be expressed in a complex form like this. So therefore, as a conclusion, our x value, our x component is 6.43 and our y value is 7.66. This point here can be expressed in two ways. One is at 1050 degrees and the other one is at 6.43 and 7.66. And that's how we explore polar coordinate form into Cartesian coordinate form and also into a complex form.